Hi, I'm Shangamitra Das from San Diego State University, and this is a short presentation about our recent publication in the IEEE Transactions on Antennas and Propagation titled Design of a Highly Miniaturized, Inherently Matched Spherical Folded Dipole and Evaluation of its Quality Factor. Dipole-like antennas are perhaps the most sought-after antenna type that are used in a wide range of applications. When miniaturized, these antennas suffer from poor bandwidths and matching problems. The technique described in this work attempts to address both the problems simultaneously. First, the principle using which an arbitrarily miniaturized folded dipole antenna can be matched inherently with respect to a wide range of source impedances. For this, one needs a simple series inductive and capacitive loading. Series inductive loading provides miniaturization, whereas series capacitive loading introduces a new resonance FRN before the first entry resonance FAR1. Matching is obtained when FRN and FAR1 are brought close to each other by varying the loading value. Here is the proposed spherical helix-loaded folded dipole antenna. The inductive and capacitive loadings are realized by the helical arms and the parallel plate capacitors. The spherical shape enables occupying all the volume inside the Chu sphere, thus maximizing the bandwidth. Here are the impedance and S11 parameters of the proposed antenna. The operating frequency is 515 MHz, where the antenna is 85% miniaturized. A very good 41.6 dB return loss was obtained with respect to a source impedance of 100 ohms. The 3 dB and 10 dB return loss bandwidths are 7.41 MHz and 2.42 MHz respectively. These are the radiation patterns at 515 MHz. An expected omnidirectional pattern was seen with a broadside gain of 1.28 dBi and high core to cross pole separation. The radiation efficiency was found to be 87.1%. Next, another prototype with an improved bandwidth and radiation efficiency was developed. For that, simply the number of folded arms was increased from 2 to 4. Again, a very good return loss was realized. The bandwidth now is slightly wider, 8 MHz and 2.60 MHz at 3 dB and 10 dB levels. The pattern is still omnidirectional with an improved broadside gain of 1.46 dBi and radiation efficiency of 90.6%. The quality factor for the antenna was estimated from its input impedance response, which is QZ, and from its bandwidths that are QBW. As it can be seen, both are almost identical and none of them actually violates either the Chu lower bound or the Thal lower bound, which is 1.5 times of that of the Chu lower bound and is more appropriate for spherical electric dipoles. At 515 MHz, the estimated quality factor is 1.83 times of the Chu lower bound and 1.22 times of the Thal lower bound. As of now, an equivalent monopole version is in the process of being fabricated and measured. Lastly, we'd like to thank the IEEE Transactions on Antennas and Propagation for featuring our article in What's Hot in Antennas and Propagation video series. Thank you.